Hey everybody, welcome to Trig Topics. Today, Alie and I will be teaching you guys about the wonderful law of cosines. First off, what is the law of cosines? The law of cosines can be written as either cosine of A equals b squared plus c squared minus a squared over 2 times b times c, or as a squared equals b squared plus c squared minus 2 times bc times the cosine of A. And the difference between these two is basically that this is utilized when you're more looking for an angle measure, and this is utilized when you're usually looking for a side length measure. So that's just a good thing to keep in mind while you're working. So these two equations, aka the law of cosines, are utilized when you are given a triangle problem with 2 side lengths and an angle in a side angle side format, or 3 side lengths and no angles. These triangles don't have to be right triangles because SOHCAHTOA is available for a right triangle, and why would you use this when you can just use SOHCAHTOA? These also, as there is at most only going to be one given angle, the law of sines cannot be used because you require at least 2 angle measures to complete the law of sine equation. Now, what does each variable in the equation actually represent? So what do these all mean, basically? So if we have a triangle where you have your angle of A, which is going to be this right here, and you're finding this side length of A here, then you would plug in the side length of B squared and the side length of C squared into here and here, and then just the normal side lengths of B and C, along with your cosine of whatever your angle measure is, and you'll solve, and you'll be perfect. So now, basically, on the topic of solving, Alie is going to show you guys a few simple problems that are going to allow you to understand the law of cosines a little better.
Now you know what the law of cosines is, but how do you solve it, you may ask? Well, when given a triangle, this triangle happens to be side angle side, but you can also use law of cosines in a side triangle, but this one just happens to be side angle side. So that's why we're going to be using this formula: a squared equals b squared plus c squared minus 2bc times the cosine of A. Doesn't really matter what formula you use this one. I just like using because you already have the variable that you're trying to find isolated. So, B is 40, C is 32, and angle A is 58. So we can plug in those values into the formula to get a squared equals 40 squared plus 32 squared minus 2 times 40 times 32 times the cosine of 58. And then we just solve it. Make sure you're very careful to not let any careless errors come your way. And then when we get to the bottom, we're going to get a squared equals 1,267.456. Remember to take the square root of both sides, because you need to get rid of a squared and just make it a. And when you do that, you will end up with a equals 36. So that's what this side length is. Side angle side. Boom, you got it. But what if we have a side triangle as portrayed here? What do you use? Well, personally, I like using the cosine of A equals b squared plus c squared minus a squared divided by 2bc. However, as Fisher and I said before, it doesn't really matter what formula you use, just as long as you get the right answer. So I'm going to be showing it using this example. So we have the values of C, B, and A, the side lengths of them. So we're just going to plug them into the equation, do some basic solving, and then the bottom is where it can get funky. So you're going to be left with a fraction. So in this particular problem, I was left with 1,328 divided by 2,560. And when you divide these, you're going to end up, or you should end up with a decimal. If you do not end up with a decimal, I will show you why that matters in a second. So you're going to divide by the cosine, and you're going to get a equals the inverse cosine of 0.518. Now, if you don't have a decimal, you will find that in your calculator you're going to be left with an error. And that is because of one simple rule. When you learn about cosine graphs, the parent graph of that looks like this, where it only covers values from -1 to 1. So if you have a value greater than that, then you're going to get an error message, so it doesn't work because the values only range between -1 to 1. So you're going to follow through with solving, and you're going to find that angle A equals 58 degrees.
Wow, those were some absolutely great problems, weren't they? Now, if you're like me, you're probably asking, how the heck can those problems help me in the real world? Well, actually, the law of cosines can be extremely useful in the real world, as I'm going to show you right now. Alrighty, so basically, one example of a real-world application for the law of cosines can be seen in this problem. So, a plane travels 130 miles at a bearing of 40 degrees west of north. Then, it changes direction and travels 135 miles at a bearing of 50 degrees west of north. So how far is the plane from its original position? So first off, obviously you want to start by drawing your triangle. As I've done here, you have your side length of A, which is your unknown, and then you have your side lengths of 130 miles and 135 miles. And then you're also going to draw in your angles. Here, first off, you know that it's going at 40 degrees west of north, so you draw to 40 here and make that line. And then you know, obviously, because 90 minus 40 equals 50, the rest of this is 50 degrees. And then you up here, and you know that you're going at 56 degrees west of north, and 90 minus 56 equals 34. And then you can basically, you know that 90 exists in here, and then you see that this is going to be an equal angle to this. So you would write 50 here, and then 40 in here for the remainder. So that's just a good starting point. You have your picture, and you can go from there. So we're going to do our cosine equation of a squared equals b squared plus c squared minus 2bc times your cosine of a, which in this case is 164 degrees. And you know this because you would add 40 plus 90 plus 34, aka these three values, to get 164 degrees. So basically now you plug in 130 squared, 135 squared, minus 2 times 130 times 135 times cosine of 164, and you come down and you get 16,900 plus 18,225 minus 35,100 times negative 0.96, and when you combine all of these, you're going to get 68,865.28. But remember, you're not done yet. You have to square both sides, and then once you square both sides, you end up with A equaling 262.42 miles, and that is the total distance of the plane from its original position. There you go. Alrighty, so here is another application of real-life law of cosines in relation to finding bearings and ships, which is very useful in real life. So one of the duties of Navy ships is to monitor the waters for pirate ships. And two Navy ships triangulate a pirate ship as shown below in this lovely triangle I drew you. So the USS Kaufman, represented here, is 86 miles due west from the USS San Jacinto, which is right here, in the ocean. The USS San Jacinto picks up an unknown signal, which is a pirate ship, about 30 miles out, and the USS Kaufman picks up that same signal 60 miles out. So now your goal is to determine the bearing from each Navy ship to the pirate ship. So basically you're trying to just find the degrees that each of these ships is in location from the pirate ship so that you can find its location and obviously track down that pirate ship and arrest the pirates on board. So basically, you're going to use your cosine equation, and a good thing to do is to break up your kind of workspace into different sections so you can keep yourself organized. So we can start off here with our cosine of A. We're looking for this angle here of the USS Kaufman. And so then we plug in 60 squared plus 86 squared minus 30 squared, because obviously 30 is A, and you're plugging A in here, and then you have B and C here, and B and C here, obviously, and following with the equation. So you plug those in over 2 times 60 times 86, which then equals 10,096 over 10,320, which you then divide, and you get 0.978, and you stick 0.978 into the inverse cosine equation, and you'll get 11.96. So your final answer for the bearing of the USS Kaufman is the Kaufman is bearing 11.96 degrees north of east of the pirate ship. And then for your next one, you're going to be doing your cosine for your angle C. So basically you would plug in 30 squared plus 86 squared minus 60 squared, because now in this sense, you're relating your angle directly to this side. So you would switch this up a little bit, over 2 times 30 times 86. Then you plug that, you kind of solve those out, and you're gonna get 4,696 over 5,160. You divide that, and you'll get 0.910, which you'll plug into your inverse cosine equation, giving you 24.48 degrees. And then you would rewrite that as 24.48 degrees north of west. And as you can see, for both of our cosines, you plug this in. Both of these were between 1 and -1, so it works as a triangle, and you solve through, you got your answers, and you're done. That's it. So now that you guys have the basic structure down of the law of cosines, and you understand like the real world impacts, Alie's just going to take a second to demonstrate a few common mistakes that can occur when you're dealing with the law of cosines.
Okay, so like any math problem would have, you run into common mistakes, and these are ones that I find to be the most common when you are calculating the law of cosines. So the first one is having your calculator in radian mode instead of degree mode. There is a simple fix to this. You go on your lovely graphing calculator, not sponsored by Texas Institutes. You're gonna turn it on, and then you're gonna go to mode, and you're gonna go down, and you will see that radian is highlighted. It should not be highlighted. So go to degree and hit enter, set second quit, and you are good to go. And then the next mistake that I found to be very common is when you are referring to bearings. When it is read as east 32 degrees of north, you are going to go from due north east 32 degrees like this. However, when it is north 32 degrees of east, you are going to go from east, and you're going to go up 32 degrees north. So you can see how these can be very confusing, but once you get the hang of it, you will handle bearings in no time. And then you can also run into basic calculation errors, such as when you are looking to find the angle measure and you have cosine of A, for example, equals like any number like 0.98. When you divide by cosine, you're going to get A equals cosine -1 of 0.98. So remember that the cosine would change to cosine -1.
I'm not gonna lie, I have made a lot of those mistakes before, but now you at least know how to avoid them. Thanks so much for joining us today at Trig Topics, and remember, don't give up and always be willing to ask for help in math. And we'll see you in the next video.